Hi, my name is Clarke, student number 1201293. In this video, I am going to be discussing the prototype that I have built for the Advanced Games Engine Architecture module, and how I have planned each stage, the building of the game using a mixture of C++ and blueprints, using source control, aka GitHub, software engineering patterns, and how this prototype will eventually lead to the overall artifact. So to begin with, I'm going to be showing you a basic end-user play perspective, then go into detail on each point. So if I just begin by pressing play, you will see a opening menu. And clicking the button and the use of a matinee, you will be loaded into this game. So some of the features in this game are you can pick up collectibles with an appropriate key. In this instance it would be E. You can sprint by holding down the Q button. A big feature in this game from a third person perspective is that you can pick up weapons off the floor, as you can see the two based in front here, and there is debug text that says I just picked up a shotgun and I just picked up a pistol, and if you press the appropriate keys for one you can shoot with that gun, and with a mini inventory system you can also shoot with the shotgun, so you can actually wield the two weapons. Another feature implemented into this game is AI enemies, and if the enemies see you, they will chase you and attempt to attack you, as demonstrated. As you can see, they're running towards me. As you can see, the enemies have gone back to their positions, and once they see me again, they come after the player. Seeing the prototype and the features that it now presents, I'm going to be moving into the planning stage. And in this I'm going to be discussing the priorities of why I've done what I did and when I did them. If you look at this, you can see that level design was my number one priority. The reason this was the number one priority was because I had to consider other factors that the level design will inevitably come to. For example, things like, where am I going to place the AI? What kind of weapons do I want? Because if I was building a small level, I wouldn't need a weapon like a sniper rifle to be implemented. I could just work with a pistol, an assault rifle and a shotgun. So I had to consider those aspects, as well as what kind of collectibles and what kind of destroyables. After I decided this, level design wasn't really difficult, but it was time consuming to build. After that, I then looked at the weapons and thought, this has got to be my second priority. The reason is, it is the most difficult thing that I've had to build in this prototype. I had to consider, how am I going to pick up the weapons? How am I going to shoot the weapon? What kind of inventory system and how am I going to get this inventory system to work? And the destroyable actors, because it would be useless having a gun if you're not actually going to have it to do anything. So I gave this the most time, week overall, and they were given a difficulty of 7 out of 10, 9 out of 10, and the destroyables was rather easy because it was just building a U-static mesh, but it was all part of building the weapon structure. Building the AI was the third one, as AI is required to make a game, and if it didn't have a game feel to it, it wouldn't be a game, it would just be a person running around a map with a weapon, destroying a few things. So having AI was something that needed to be in the game. When it came to the menu system, however, this was something that I said in the comments, this may not be necessary depending on if I need time back for other features, which I did. I only managed to increment the start menu, but I had to pull some time back as I was having issues with AI. Moving into the next section, I have considered some of the tasks that I want for my overall artifact, what I want to increment during the next period of time. But for this moment in time, this is just a bare landscaped feature. I'm pulling up a Gantt project of where I thought the dependencies were. So I tried to make a waterfall feature where if one thing influences the next. Now I do realise that the AI doesn't directly depend on if the weapon is built or not, but like I said earlier, due to difficulty, it was, in my opinion, key that it followed this order. So, moving over from project to Trello, as you can see, my completed list it shows the design level has been completed, things like the AI have been completed, the start game menu has been completed, and the guns have been completed. The two remaining things in my original to work list, which will now be pushed over to the building of the final artifact, is the pause menu and the end game menu. This is because, as stated earlier, the AI did take a little bit longer than necessary and I did need to pull some time back, which resulted in pause menu and the end game menu being left out. Whilst working on my prototype, I have been using source control in the form of GitHub. GitHub has been really useful in the time I have used it during the prototype stage. For when I did my initial commit, it sent all my files to the server, and since that point it has only updated the files that have been modified or added. In comparison to having used Dropbox, and every time a change or file addition is being made and needing to re-upload the entirety of the project, GitHub has saved me a lot of time while using it. I will continue to use this while I work on the final artifact, as it will just be building on an already existing prototype. This is a basic QML diagram that I designed while I was writing in code. You can see the weapon class takes on the role of a factory, the pistol and the shotgun, and obviously in the future if I want any more weapons then it can just be weapons in the future build of the game, but for the moment the pistol and the shotgun are always deriving from weapon, and basically all I need to do is call a new class that derives from the class weapon. The target will be something that can be destroyed by the weapon, so it does need to be linked so that weapon knows what target is, but the target will only actually consist of a skeletal mesh that you can get the on overlap later. Then you have your individual game character, which needs to be aware of the equipped pistol, the equipped shotgun, on collision, hit result. In the terms of pickups, you have a pickup function and a dossier pickup, which basically is the pickup there. If it is, do you want to pick it up? And this overrides that on pickup implementation to say the pickup can be destroyed. And then there's also this mini inventory system up here where it says create a tier A class of a weapon, so basically anything that's in the weapon that can go into this inventory system. A weapon is current weapon, which basically says whatever weapon I'm calling is the current weapon that I'm holding in my hand. Looking at the code, this is for my weapon.h class. In this you can see I have a range of functions, ufunction void fire, ufunction void instant fire, weapon config. I have an enumerator for the projectile type, sub-object pointer of ubox component to access for collisions, and a sub-object pointer for the weapon mesh. This is the enumerator. I have three types. I have a bullet, I have an E-spread for like a shotgun style range, and an E-projectile if I ever decide to increment a rocket launcher. If I just go down to the U-stroke, this has a few properties in it for if I wanted to have a max ammunition for my gun, a time between shots, so if I wanted my shotgun to take about 3 seconds to shoot one bullet, shoot another bullet, shot cost, so that it could be like a triple shot pistol or assault rifle, so it would have to take 3 off. Shot range, obviously there's going to be different ranges for the assault rifle, the shotgun, the pistol, the sniper. Bullet spread, that'll be range for shotgun every time it spreads out, and the name of the weapon. Further down you also have F hit result weapon trace, so I'm basically saying I want to trace where it's coming from and where it's going to. And I also have a void process instant hit function which calls the hit result, the vector from the origin of where it was shot, the direction in which it's shot, the random seed and the reticle spread are to do with the spread of the bullet, aka the shotgun. When the random seed is played, it will mean that the spread will never repeat the same. It will be using an F math random to process each shot, so it will randomize. This will be shown later on when we go back to playing the game. And the reticle spread is the actual width of the spread of the bullet, which again will be messed around with when I show it later on. Into weapon.cpp, you can see that I have set the collision component, the U-box component, and set the root component to the collision component so that it actually has world movability. Weapon mesh, I've also created the default object, skeletal mesh component, and then I've just attached that to the root component again so it has movability around the world. The create default sub-object, from what I've understood, is kind of like a factory where you can just create many of these things. In the fire function, I'm calling the E-bullet and the E-spread and the E-projectile, but in this instance I have no need for the E-projectile. The E-spread and the E-bullet will both be calling the instant fire function, and I will be showing you the differences later on. I just wanted to show that this is where they are being created. This is my instant fire function. As I stated earlier, random seed will be calling fmathrand, so it's basically calling random numbers, and the random generator keeps going through those numbers for every time I want weapon spread to be called. This is where you are setting the spread of the weapon, so current spread will go to the bullet spread. This is creating a cone, but when you convert it from degrees to radians, you only have 180 degrees, which equals 1 radian, which is why when you times by 0.5, instead of having the 180 degrees, you'll have the full 360 degrees. And then you're setting it to the gun socket, which if I just show the Unreal area, there is the MF, which is what's being called. MF and go with the vector, the direction of what it's aiming in, and the start trace goes from that same location. The shoot direction is cone for the spreading of it, is the comment above states, where it says the direction that this gun is facing and calling the spread cone twice to make it go in a forward cone motion instead of creating a grenade effect and just blowing up. Saying is, instead of it just going all over the place, it will be coned in an outwards direction away from the gun. And trace is calling the start trace, the shoot direction, and the range of the gun, which if I go back into Unreal and then go to the weapons, you can see that I've got a shot range here. So this is how long the end trace will continue on for. And then the process instant hit calls the impact, calls the start trace, gets the shoot direction, gets the random seed, so basically for the spread, and gets the current spread volume and sets it to weapon spread. In this weapon trace function, I'm calling the collision query parameters, and I'm basically asking, do I need the bullet to return in the scene? Which yes, I do. Do I need to return physical materials? Yes. And does it need to ignore anything? In this case, yes, it needs to ignore the gun. I have the last function, which is process instant hit, which says get the end trace. If the end trace hits an actor before it reaches the end, stop at the actor, otherwise continue to the end of the trace. And further down here, these are basically saying if this bullet hits an actor, in this case it's the enemy actor, which is the target that was shown right at the very beginning, it will say destroy this enemy. So this is my current pistol.h file. As you can see, there is no actual code in it, just that it was created in the Unreal Engine based on public A weapons, because all it needs to do is be based off the weapons class. This is the enemy.h, which again links back with the weapon class, and as you can see, all it is calling is a sub-object pointer to a uStatic mesh component. And if you go into enemy.cpp, it's basically creating the enemy mesh and setting it to root component so it can be moved around the world. Now moving on to the pickup.h file, and then I will eventually get to individual game character. So I'm calling a uProperty function, edit anywhere. I want it to be editable in both the blueprint and it can be read in the blueprint. I'm asking, is this pickup active? I want to set a sphere component for collisions around the object. I want a static mesh so that I can see the object in the world. And also I'm calling a blueprint native event that says onPickedUp, which will be being overridden in the dossier pickup class, which will be coming up next. So in the constructor, what I'm saying is yes, this pickup is active, and in dossier pickup later I'll be saying once you've picked it up, it's false, destroy it. Setting the base collision component back to the factory so that I can get a set of uSphere components, and I'm setting the root component to the base collision component so that again the collision sphere can move around the world map, move around the location of the scene that I've created. I'm creating another factory of static meshes called pickup mesh. So basically there is a mesh in the world, and then I'm telling pickup mesh to attach to the root component. So basically the root component is the base collision component, and the pickup mesh is attached to the collision component also. And there is no default behavior on the onPickedUp implementation. This is the dossier pickup.h, and this only has one function, which is to override the onPickedUp implementation that was in pickup.h. This does not need a new U function, as it was a blueprint native event and it is calling the old onPickedUp implementation function, which has a U function above it. And all this is saying is call the parent implementation and then destroy the actor once you've picked it up. And finally, this is my individual game character.h. In this I have many functions, including the collect dossier function, the onCollision function, the equipping of the guns function, the inventory function, the fire the weapon function, the weapon spawn function, creating collisions, box components and sphere components, and also the start sprint and end sprint. So I'm going to start off with the sprints and then go to the collectibles and then go to the weapons. So to begin with, you have the set up player input component, and in this, as you can see, fire, collect dossier, pistol, shotgun, start sprint and end sprint. The two that we're focusing on at the moment is start sprint and end sprint. So what happens is start sprint is being called when a key is being pressed, and end sprint is being called when that same key is released, and it is calling the functions from individual character.h. So if we just go to default input, you can see here I've action mapped start sprint to be key Q. So when key Q is pressed, start sprint will activate, and when key Q is released, end sprint will activate. If I scroll down, you can see that the two functions are actually saying the character's movement at the max walk speed when the key is pressed should go up to 1500 as if he is sprinting, and if the Q key is released, the end sprint function will be called and the max walk speed shall return back to 900. So as you can see, he's running, and if you hold the Q key you can clearly tell the difference in how quick the character is moving. Inside the character Inside game character.h, I'm now going to be discussing the collectibles, and as you can see, this is where I'm setting the collision sphere collectible, and down here is where I'm calling the collect dossier function. So if I go into my game character.cpp, you can see in this I'm creating the default sub-object of the uSphere component, and I'm attaching it to the root component again, and I'm setting the sphere radius so that it is 200. If you're going to collide with an actor, get that actor's particular collected value and then cast that to the iCollected, and if this dossier is still active, call the dossier on pickup and be active is false. So if I just go back to dossier pickup.cpp, it's calling this on picked up implementation, which is also saying destroy the actor. As you can see, this is the collect dossier function, and basically what this function is saying is, so here we are back in the game world, and as you can see, this is one of the collectibles that I have placed in the map, and if I press the appropriate key, the code is read and the actor is destroyed and made false. The last part of my individual game character.h is the weapon. And as you can see, I have a U function void fire weapon, subclass of the class A weapons for the inventory system. A weapons pointed to the current weapon, the equip pistol and shotgun, and the U function for an on collision with the weapon being placed in the world. This is my constructor, and in this I've told the current weapon to be set to null, so when the game begins I don't want the player to be carrying any weapons with them. I've also set the inventory size to 2, and I don't want it to shrink, so I set that boolean to false. As you can see here, I have set the weapons collision component, that is again calling the U-box component per weapon that will be created. I've attached it to the root component, so again it can be moved around the map, and this says on event begin overlap, so basically if something else overlaps it, call this function, and this function is on collision, which will be picking it up, placing it in the inventory system, and again same with this one, picking it up, placing it in the inventory system and destroying the mesh that's in the scene. This first function, fire weapon, says if you haven't got a weapon you can't fire, but if you have got a weapon then you can fire it. Going to the next one, this says you're getting a pistol and you're going to cast it to a pistol or the actor, and if you do hit the pistol, set it to inventory slot 0 and get the class of pistol, which would then lead you to the class of weapon, put a debug message onto the screen saying I just picked up, and then that's where you call the name function to say I've just picked up a pistol, and then destroy the pistol in the world, so the mesh will no longer be there. This is the last function, it's the equip pistol function, and in this the only difference between the equip pistol and the equip shotgun is that this inventory slot will turn to 1 for the shotgun, whereas in this it is inventory slot 0, which is slot 1, because 0 is 1 and 1 is 2 in C++. So then you have this if statement that says basically if I have a weapon in my hand and the weapon is the same name as the weapon that I already got, then set the inventory space to null, destroy that weapon, destroy the socket that it was attached to, and delete the collisions that were enabled on it, and then create a new weapon of spawner based on the current inventory system that you've just picked up, and then just put a message on the screen saying that your current weapon is whatever the name of the weapon is, which in this case would be pistol. Else, you've got to do a check to see if the weapon does not already exist in the player's hand. So if the weapon that you've just picked up and called it to the socket, you can't destroy a weapon that isn't there or it would break the system. So this is the last part of the code in action. So as you can see, when I collide with the shotgun, it picks it up and it places the debug text, I just picked up a shotgun. Then if I pick up this pistol, it says I've just picked up a pistol. Then if you press the key 1, it goes to the pistol slot, even though it's an assault rifle, because that's the only mesh that I currently have. And same with the second one, it says it's a shotgun. And back to 1 and 2, and also if you shoot it, as you can see, the ray traces are being made, and also the fact that the weapon is destroying the target meshes. So you can see again it's outputting to screen, and you can see that also even in this Spectre that some of the ray traces are very dissimilar, where at top some of them are heavier, and then if you go to this one you can see where they've scattered out more. So just doing some more over here, you can see there's two very different ray traces even just inside the small circle that the spread has allowed them to have. So this is the level blueprint for the main menu. As you can see, when the game starts, I want to create a widget that will add it to the viewport, and also I want to be able to see the mouse cursor. So if I press play, you can see that the UI widget comes up on the screen and you have access to all the boxes, and the music plays in the background as shown here. This is the level blueprint for Castle, and when the game begins, the actor will change the rotation of the light source, is how bright the map is, and then it updates the sun direction, so basically the sky sphere, and it rotates so that it goes between night and day. This node here, if changed, will clearly demonstrate how quickly you can turn from night to day. As you can see, we're going from night back to day. So this is the AGEA guard character, and in this, when the game begins, we want to get the blackboard of this particular character, and we want to set it the target that is in the blackboard, and get the key name based off the name of this target. This is the AI guard controller, and this is linked with the AI guard character as shown in Castle here. The AI controller class is calling the AI guard controller. In this, when the game begins, it's saying run the behavior tree. So basically, going to the behavior tree, when game begins, this will be set so that the AI guard character can react to these situations within the game world. The on see pawn is a sensing for if the character sees the player, and going back to the behavior tree, if it does see the player, then it should be doing these actions. So it will move to the player, it will play the animation, it will attack the player, and it will then wait 2 seconds, and then it will go back again if the enemy is still being seen. If not, it will run down the list to the guard target again, and then go to the idle behavior if all behaviors have been run. And the same applies with hear noise. If the noise is heard, if you're within the range of the enemy and you press the key, the guard will go to that behaviour. So has heard noise is called, move to that noise location, wait at that noise location, then reset heard, so heard goes back to you've not heard anything, and the behaviour tree will run again until it gets back to the idle behaviour. This is the blueprint task for attacking the player, so the enemy will be attacking. So when this event is received, which in the behaviour tree is if the enemy is seen and after it has moved to the enemy, it will play the animation, and then this task will be called of do attack, and it will say if it's valid, apply damage to that target, and the value of the damage is 10. So just in terms of overall where I am in progress to the ending artifact, if I just go back to my Microsoft Word for planning, as you can see, a lot of the main things that have to be covered for the key mechanics to the game have been created during this prototype stage. At a later time I will be covering these this list here, which is animations, first person scope zoom for aiming weapons, put in some hostages and also gaining some hostage behaviour, scoreboards and timers. In this I want to create a scoreboard for time recorded, create a timer for killing all the enemies, saving all the hostages, collecting all the collectibles, and depending on time gained back at a later stage I may consider further increasing the level design, which may give me new ideas that I have not thought of currently.